Let's look at these counting problems. I hope it is kind of a fun thing, but you have to really think a little bit about it, right? So, okay, so number 25 is about strings of decimal strings of length 3, okay? So the first one, A, asks you how many do not contain the same 3 times. The same 3 digits. So for instance, 0, 0, 0 would be excluded, and 1, 1, 1. And there lies your answer, right? So very often when we exclude something, what we're going to count is how much is all possibilities, and then what are the invalid ones, and then the actual ones that you need, the valid ones are then the difference. Okay, so let's look at the all possible strings. Well, how many are there? The number. I always write this kind of number sign to say the number of these things. Well, it is the product. We have to make 3 positions, and we have to put in 0, 1, 2, all the way up to 9, which are 10 possibles. Okay, so the 10 choices here, 10 choices there, 10 choices there. They're totally independent of each other. So it is 10 times 10 times 10. So that's 1,000. Of course, we know that because there are 1,000 numbers. Okay. Sure, okay, that's that, to not contain the same 3 digits. What does that now mean? Well, let's therefore calculate that all digits the same. So how many are there? Well, what is then? How do you build a thing like that? If you need to build a number in which all 3 digits are the same, well, you pick a digit, say 5, and that's it, because now this has to be 5 and this has to be 5. So how many choices you had? 10, right? Okay, and so then the answer here is then, well, how many valid are there that do not contain the same 3 digits? It's 1,000 minus 10, so there's 990. Okay? Then question B is begin with an odd digit. Okay. So let's think about how would you, so always try to solve this problem is how would I make a number that satisfies this, right? What procedure would I follow? Well, it's actually rather simple, right? I have to begin with an odd digit. So for this, how many choices I have? Well, half of the many odd choices, 1, 3, 5, 7, and 9. So 5 choices here. How many choices I have for the next digit? Well, there's no restrictions, so I have 10, and here also 10. And again, everything is independent, so it's multiplying, and so this would be 500 digits. We begin with an odd digit, which of course makes sense. Half of them will be odd. We start with an odd, and half of them will be an even. And then C, that's perhaps a little bit harder. Have exactly 2 digits that are 4. Okay, so how would we build a number that satisfies this? Let's think about that. Well, the first thing I have to choose is the problem is, okay, so what is a valid choice? Let's look at valid choice. So for instance, 4, 4, 7 would be a good one, but also 4, 7, 4. Okay. What about 4, 4, 4? That's also a correct one, right? It contains at least 2 digits. Okay. Now we have to keep that one in mind. So what way you could do? You say, okay, I choose my other digit, okay, my third spot, because the two spots are taken by a 4, and there's an empty spot. There is a candidate, okay, and the candidate, but where is he going to be? So I have 3 possibilities, okay. So it is spot 1, spot 2, and spot 3. Okay, so let's see how many possibilities are. So this is the other digit. That's what I mean with the spots, right? These are the spots of that other digit, the one that might be different from 4, like in this case 7. In spot 1, how many choices do I have? Well, I have 10 choices, right? So this, right? So this it's spot 1. This means these are numbers of the form these kind of numbers. Spot 2, yeah, sorry, I'll do it up here. Spot 2 would be numbers of this form, right? And spot 3 would be numbers of this form. It's the empty spot that I'm counting, right? Okay, so I have 10 choices for this digit, so 10 choices here, 10 choices there, and 10 choices there. But there is a problem, because I'm counting something too often, namely exactly this guy here. Because when I took 10 digits here, I allowed that to be 4. But if I choose a 4, if one of these 10 choices that I had here would be a 4, but that another way of making the same number would be have taken a 4 here. Okay? So what could you say is, well, how many times did I get the number 444? Well, I got it once here, once there, and once there. But I'm supposed to only count it once. So one way of getting out of this is say, what's the rest? These are now ORs, right? It's either in spot 1 or spot 2 or spot 3. So this is the sum rule. So the sum, so the total number would be, 10 plus 10 plus 10, but twice I counted 444. I counted it, in my count it appears 3 times, which is twice too much. That's why I have to subtract. So in total that would be 28. There's another way that you could solve this. So this is solution 1. Another solution is that you say, okay, I'm gonna avoid that trouble guy. I'm not gonna make 444. So let's not, so when I do in spot 1, I'm gonna choose everything but 4. So how many choices do I have then? 9. Sorry, I'm not writing down. You hear me what I said, right? 9 and 9. So that's in total 27, because it's again adding. But, of course, this is a valid number, so I have to add plus 1 to it, plus 1, and you see it comes out to be 28. So I repeat a little bit, perhaps a bit red. 9 means I have 9 choices to put something here that is not a 4. 9 choices to put something here that's not a 4, and 9 here. Okay, it's one of these 3, so I have to add them up. This gives me all numbers that contain 2 digits that are equal to 4, except one number, this one. So I'm adding that in my count, and that's why I can get that. Okay. Yeah, you see, all these counting problems, there's always something, you cannot just say, oh, it's just one simple formula. You have to think about these things a little bit. Okay, so the next one was 33. Okay, that's with a lot of strings and letters. So we have an alphabet, the English alphabet. And okay, here is my quibble that I have with the book. So I'm going to do different than the book, because for me the vowels are, so this is a bit of a definition. What is a vowel? Well, everybody agrees that these are the vowels, I hope. But Y can be a vowel. Very often it is a vowel. So for instance, if I say plenty, the I on the end of it is a vowel there, right? Because it sounds plenty. With vowels you can make them as long as you want. You cannot do it with a consonant. Plenty. That's stuttering, right? Okay, so hopefully that's the difference. Now, Y can sometimes also be a consonant. So it's what we call, it's normally called a semi-vowel. But I'm counting it as a vowel, just to be contrary to what the book does. So that you think a little bit, you get different answers. Okay, 33A asks how many contain no vowels if letters can be repeated. Okay, so let's think about what we have here of length 8. So this always of strings of length 8. They say sometimes words of length 8, but when they say words, you cannot take it too literally. They don't mean an English word. They mean a gibberish word, like a code word of something like that. For instance, a YouTube movie has consists of like letters and like that. Okay. I mean the address of the file name. Okay, so 32A, how many contain no vowels? Well, okay, 1, 2, 3, 4, 5, 6, 7, 8 spots, and in each of these 8 spots I have to put something. And how many choices I have? Well, I cannot choose a vowel, so of the 26, I have 26 of them cannot use. So 20, 20, 20, 20, 20, 20, 20, 20. Now the big question is, what do I do with the 20s? Add them or multiply them? Since every choice is independent and I have to end up with 8 choices, it is multiplication, right? So the total number, so it's all times, I'm not going to write this, so it's 20 to the power 8, which is a big number, so I'm not going to even calculate that. Okay, so B, okay. 33B is same but no repetition. Okay, we haven't done this, but it's, I think there's an example in the book that I want you to read, but okay, let's do this now. Okay. So I'm going to build it again, and again I can only choose the consonants, which are 20 of them. So for the first one, I have 20 choices. Let's say I picked Z there. I like that letter, so I picked Z. But then in the next spot, I cannot use Z anymore. So how many possibilities do I have left then? 19, right? So I have only 90 possibilities for this one. Say I put B. So now Z and B are used. So for the next one, I cannot use either two of them. I can never use a vowel. So there's 18 left. Okay, and so I hope you get it. This is 16, this is 15, this is 14, and this is 13. So the total number, so the number, if you want, is 20 times 19 times 18 times 13. Sometimes people write this as 20 factorial divided by 12 factorial. I'll let you think about that. Why is that the same? But it's shorter way of writing it down. Okay, C, 32C, that start with a vowel if letters can be repeated. Okay, so what is changed now? I don't know why they made this length 8 because it's so long. Okay, so it has to start with a vowel. So here I have now 6 choices, my 6 vowels. I remind you the text in the solution of the book, they use only 5 vowels. So instead of 20, they will have 21 consonants. So the numbers are different. Okay. So 6 here, and now what about the rest? Well, there's no condition there. We can repeat them. So we're gonna have 20 here and 20 there and so on. So this is gonna be 6 times 20 to the power 7. Right, because there are 7 remaining spots where I have 20 choices. Sorry. No, sorry. Start with a vowel, but then sorry, it's 26, right? Because there's no restriction, so it's really 26. So it is 6 times 26 to the power 7. What if 33D says same thing but no repetition? Well, I don't have to worry about the vowel because, I have to worry about the vowel, right? So, okay, so here so I have 6 choices for my vowel. Yeah. Now I cannot repeat. So how many choices I have left here? Well, I can choose whatever I want. It doesn't have to be a vowel, but I cannot use the vowel that I just used. So here there's only 25 left. Okay, and now I used already 2 letters, so 24 left. And I hope it is clear now. So, and at the 8th spot, well, okay, what is that? 23. 1, 2, 3, 4, 5, 6, 7, 8. So 23, 22, 21, 20, and 19. So I get 6 times 25 times 24 times times, what does it say? 19. Okay. 33F. That's no, 33E. Yeah. At least one vowel, but there is repetition. So yeah, that's already much harder, right? So how am I going to do that? Because the vowel could be anywhere. Okay, and there could be more vowels. Okay, so what would you do then? Let's think about how to solve this nicely. You could try to enumerate all possibilities, but if it has to be at least one vowel. Well, let's look at the words that would violate this rule. Do I know how many there are that violate the rule? This would be all the words of length 8 that do not have a vowel. Yeah, but wait, I calculated that. This is this number. These are the ones that do not contain a vowel. So these are the bad ones. Now, how many in general are there? So the total number of words of length 8 is 26 to the power 8, right? Because I cannot choose anything, vowel or consonant. but the number of invalid words, of all possible words, let me put it that, is 20 to the 8, remember we just calculated that here, and then finally the number of valid according to the rule at least one vowel, is then the difference. Okay, so this is what I would call a neat solution. I'm not saying that's the only solution, because we could try to play a little bit again what we did with the fours here and choose a position where the vowel goes, but then it gets really tricky, because then there are other vowels, you sometimes you would double count them. Okay, so for not double counting, this is right away the solution. That contains exactly one vowel if letters cannot be repeated. Well, it's the same thing, right? We do exactly the same thing. So 33F, we count all the possibilities, but we cannot repeat. So let's think about what does that mean if I cannot repeat. Remember, when there's no repetition, each time I have to take one less, right? If I go through my 8 choices. But of course, here now this time, so the number of possible words is I can start 26 for the first one, then 25 for the next, 24, 23, 22, 21, 20, 5, 6, 7, 19. Okay, these were the choices. This, you understand where it comes from? Okay. What's the number of invalid words? These were words that do not contain any vowel, but we calculated that. That's something we calculated, was this number. Okay, so that was 20 times 19 times all the way up to, what was it, 13? Okay, up to 13. I'm not going to think too much about it. Yeah, okay, up to 13. And so the number of valid words is now the difference. What are valid words? Is a word that has no repetition, but at least one vowel. Okay, so that would be, let me write it, box it like that. It's this number, and then this number, and the number that is sorry, it's the black box minus the orange box. Okay. Oh, there's more. So okay, the 33G that start with an X and contain at least one vowel is letters can repeat it. So start with X, at least one vowel, and there's repetition. Let me not write that down. Well, it has to start with an X, and we're building 8. Again, we're trying to build this word, right? Well, there's no choice. I have to put an X here. So really I'm building is a word of length 7, right? Because the X is, I have no choice. It's the 7 next letters I choose, and now the idea is the same. So I'm going to write down the formula. It's 26 to the power 7 minus 20 to the power 7. Let's think about it, right? Because that's exactly the calculation I came up here with. The number of possible words, well, 8 spots, I can choose 26. Now we have only 7 spots, so 26 to the power 7. The ones that are invalid, these are the ones that do not contain a single vowel. That means that each time I choose among these 20 non-vowels, consonants. So, but there's only 7 spots, so that's 20 to the 7th. Okay, and then 33H, I hope that it is now clear. You do exactly the same here. We do the same thing what we did here, except we do one less. Okay, I'm gonna make myself extremely lazy here. I'm gonna say, okay, don't take this guy and don't take this guy and don't do the same thing. Okay, because now I have only 7 choices. Oh, sorry, that's what I'm doing wrong, because now I have to take into account that I cannot even take X. Sorry, so I am wrong, right? So what I'm scratching out the wrong one. So in the original case, I cannot take X, right? When I'm building all possible words, I cannot repeat. Oh, that was not the question. But okay, I did that now. So my question was, so H was a different question. Let me not do H. H is really the same thing. start and end with an X and contain at least one vowel. It's exactly the same thing as the previous one, except now we have only 6 spots. Okay, but what I wanted to do is show you, you can also calculate that start with an X and have at least one vowel without repetition. But the thing is, that means that I cannot choose 26 letters anymore. That for this spot here, I only have 25 choices. I cannot choose X, right? So the number of possible words is this number that I wrote down, because there are no 7 spots left. But what about the invalid words? Well, if I'm trying to find an invalid word, it's again a word that cannot contain an X. So again, the same thing, right? I should not take the very first one. And then, because that's, if you want, that's taken now, right? And so now we're left with that number, and now it's what I said is correct. Okay. And then the last one, 45, yeah, they're kind of a bit long always to work this out, but there are many subdivisions, right? So number 45. Yeah. How many people are there to seat 6 people around a circular table? So we have a circular table here, and we have 1, 2, 3, 4, 5, 6. That's not very good arrangement. And so let's call the people A, B, C, D, E, F, and G. No, that's one to guide, one to manage. G is the server. Okay, so that's the guy. Okay, so how many ways are there to seat them? But when are 2 seatings considered the same? It's a bit different than in the example that I did in the lecture. Here we say that 2 seatings are the same if they have the same neighbors. So let me, and instead of 6 is a bit too much, let me do what it means with 4. So suppose, let's go back to the case. So A, B, C, and D, and A, B, C, and D were considered different seatings in the example of the lecture, because A has now as neighbor, its left neighbor is, in this case, the left neighbor is B and the right neighbor is C, and here the situation is just the opposite. But in this question, they are considered to be the same, right? 2 seatings are considered the same when everyone has the same 2 neighbors, without regard to whether they are on the left side or the right side. Okay, in these 2 are the same in our counting. We count them as the same because they are equivalent. By the way, if you want to know what's the exact mathematical term to say they are equivalent, so we should just say equal. They are equal because in both cases A has the neighbors B and C. Okay, now in 6. Okay, so how do you solve this? Well, we have to figure out how, this is a division problem, right? First we look at all possible positions that I can make. Well, let's number the spots. Let's number this spot 1, 2, 3, 4, 5, and 6. Since I'm allowed to, since 2 positions give the same, table settings give the same. If A is sitting here, I can move. If A is sitting here, I can turn the table this way, and then A is sitting on top. So I can always choose A to be here. So I can always make this A. Okay. Now I have, what are my choices for position 2? Well, A is gone, so there are 5 positions left. So I have 5 choices here. So the number of choices, 5. Now they are going to be independent, right? Because when I have chosen another one, then in spot 3 there are only 4 left. For this is only 3 left. For this one there's only 2 left, and now there's only 1 guy left. He has to sit there. Okay, that's 1. So it's 6 factorial. That's 120, right? So there are 120 seatings in which A sits in the north. Okay, but there are still seatings that give the same answer. Namely, if I would flip over, so in other words, if you think of this as you put a mirror here and you look in the mirror, then the guy that was sitting here now sits there, right? But it's still the same neighbor of A, right? So you see now that there are, I'm counting every seating twice. The seating that I get this way and the seating I get by flipping over will give me the same seating. So there are only going to be less seatings, okay? But that's let's see, is that the only thing that can happen? But it can also happen here if I would to put instead a mirror here, say, okay, and flip it around. I get now a seating in which, of course, A is not on the top anymore. Okay, so that doesn't give me. Okay, so I guess this is the right number then. I think I got the right number. So the answer is, so we there to every solution is counted twice in this way, because as I said, when I count a solution, sorry, let me get rid of the blue guy here. The blue guy doesn't play. Every solution is counted twice. Why? Because if I have a solution, another solution that would give the same neighbors to everybody is by flipping it over along this mirror, if you want, along this axis. So this means that by the division rule, there will be only 120 divided by 2, that is 60 different seatings. Okay? So this was what I said, number 45, yeah? Okay. And, okay, so what I'm going to do now next is, there will also be a quiz on this counting. We can also do a counting today. You saw the counting on Pigeonhole. That's a different principle, so I'm probably going to do quizzes on both of them. What was I looking for here? Sorry, I just want to double check that this is, 60. Just want to make sure that was correct. Okay, all right.